Hello everyone, it's me Sanjay Vasu back again for another video. This time I'll be doing it on Cambridge Primary Checkpoint for April 2024 Mathematics Paper 1. You're not allowed to use a calculator. Let's start. Question 1. Oliver draws a rectangle on a coordinate grid. He labels the vertices A, B, C, and D. Oliver translates the rectangle 4 squares down. Write down the new coordinates of B. He translates the whole rectangle 4 squares down. That means he translates this point B also 4 squares down. So 1, 2, 3, 4. It'll land over here. 5, 2. Because the x value is 5, the y value is 2. That's our answer. Question 2. Mia has a bar of chocolate. She eats 3/4 of the bar of chocolate. Mia says, I have 3/4 of my bar of chocolate left for later. Mia is not correct. Explain how you know. Well, Mia has a bar of chocolate. That's 1 bar. She eats 3/4. So the amount that's left is 1 minus 3/4, which is 1/4 of the bar, not 3/4. She says that she has 3/4, but indeed she has 1/4 of the bar only. So well, that's our answer. That's why Mia is not correct. Question 3. Angelique decorates her garden with 2 sets of lights. One set of lights has a length of 7.35 meters. The other set of light has a length of 3.62 meters. There's 2 sets of lights like that. Calculate the total length of the 2 sets of lights. Of course, we just add up the two. 7.35 plus 3.62, which turns out to be 10.97 meters, and that'll be our answer. Let's go to question 4. Here is a number, 38.04. Multiply this number by 1,000 and write the answer. 38.04 times 1,000. How do we do this? We see there are 3 zeros in 1,000, and this is greater than 1. So we have to move the decimal place right 1, 2, 3 times. So let's say there is 040 here. 1, 2, 3. So now the decimal place is here and the zeros after don't count. So it's just 38040. That's the answer. Question 5. Here are 4 calculations. Draw a ring around the calculations that's equivalent to 0.9. If you do each of the calculations, you will get 90, 0.099, and 0.9. And the equivalent calculation to 0.9 is the 4th one. Question 6. Calculate 345 divided by 15. Let's use the method of long division. We can see that out of 34, how many times does 15 go in? It goes in 2 times, which makes 30. Because the third time would make 45, which is greater than 34, so we can't do that. Now when we subtract, we'll have a remainder 4. Let's bring down the 5. Now 45, how many times does 15 go inside that? It goes 3 times, and it goes exactly 3 times since 45 minus 45 becomes the remainder 0. So therefore, 345 divided by 15 is 23, because that's the number we get as the quotient. That's our answer. Question 7. Rajiv records the vehicles that pass his house one morning. Here are his results. There are 200 cars, 50 motorcycles, 100 lorries, 50 bicycles, and 100 vans. Rajiv records the results in a pie chart. Complete the key for his pie chart. We can see that this here is vans, this is bicycles. What's the next one? Well, 200 will have the largest angle, so this will be the 200. And then 100 will have a middle angle, something between all 3. So this one looks quite moderate. This is the largest, this is the smallest angle here, so these 2 are middle angles. And the smallest 2 angles will be for 50 as the number. So since we have bicycles already here as 50, now we need one more to make 50 of a certain number, and that is motorcycles. So This pattern here is motorcycles. Next, the crisscross pattern here, the ice cream cone-like pattern. That one is in the medium angles, which are for 100 vehicles. We already have vans given here, so the other one is lorries, and that is this one. Now what's left? Cars. This is the largest angle and it's for 200 number of vehicles. That's our answer. Question 8. Pierre has 12 pieces of pizza. Each piece is 1/8 of a whole pizza. Draw a finger on the total fraction of pizza Pierre has. The 12 pieces and each is 1/8. So the total fraction will be 12 multiplied by 1/8, which is 12/8, and that becomes 3/2. 3/2 is an improper fraction, and we can make this into 1.5 as a mixed fraction. So the total fraction is 1.5 given there. Question 9. Here are the nets of some 3D shapes. Draw a ring around the net of the prism. Well, what's the definition of a prism? It has to have a perfect cross-section multiplied by a length. So let's say cuboid, that's a prism, because this rectangle which I'm drawing here is the cross-section and it's extended out to make cuboidal prism. Sorry, rectangular prism or cuboid. And similar to this, which has a net which looks like this. We'll have a pentagonal prism, which is the fourth one here, and that is the net. There are 5 rectangles, each to fit on one of the 5 sides of the pentagons. So that'll be our answer. The other 3 are nets of other figures, a square-based pyramid, a tetrahedron, and an octahedron, but they are not for prisms. That'll be our answer. Question 10. Here's a circle. It has 8 equally spaced dots around its edge and 1 in the center. Join 3 dots to draw a right-angled triangle. There are 8 equally spaced dots around the edge. So let's say you draw a line from the center to one of the dots, and then draw it from the center to an adjacent dot. This angle will be 360 divided by 8, which is 45 degrees. Now we don't want 45, we want 90. So let's take one of the lines, which we just do. Let's take not the next dot, but the one after that. That will be 45 times 2, which is 90 degrees. And we have a 90 degrees, and we can just join these 2 dots as well to make a right angled triangle. Of course, this is not the only answer. You can draw it like this, or like this, or like this, or like this. And there are actually 4 more ways you can do it apart from those which I showed already. So well, there's quite a few answers, but the general idea is that you have to draw a line from the center to one of the dots, and then from the center to the next dot after the adjacent one. And then connect the 2 dots which you drew the lines to. That's the answer. Question 11. Here are 2 sets of cards. Hassan picks 1 card from each set at random. Hassan says, I am equally likely to pick an even number from set A as I am to pick an even number from set B. Take to show if Hassan's correct, explain how you know. Well, what's the likelihood of picking an even number from set A? We have 2 numbers and one of them is even, so the likelihood is 1/2. Now for set B, we have 4 numbers and 2 of them are even, so the likelihood is 2/4, which is equal to 1/2. These 2 are equal, they are 1/2. So Hassan is equally likely. And the reason is the probability of getting even in set A is equal to the probability of getting even in set B, which is equal to 1/2. Let's go to question 12. An airplane carries 269 passengers each day. Calculate the total number of passengers the airplane carries in 28 days. If the airplane carries 269 passengers per day and there are 28 days, just multiply the 2 to find how many passengers it carries in 28 days. So 9 times 8 is 72, we carry a 7 here. 6 times 8 will be 48, add 7, 55, carry a 5. Now that'll become 16 plus 5, 21. Now 0 here, 9 times 2 is 18, we carry a 1. 6 times 2 is 12, now that becomes 13, we carry another 1. 2 times 2 is 4, and then we have plus 1 to get 5. So when we add this up, 7532 passengers. That's our answer. Let's go to question 13. Here are some quadrilaterals drawn on a dotted grid of squares. Draw a ring around each quadrilateral with rotational symmetry of order 2. Let's look at the first one, the square. A square can be rotated 90 degrees to come back to its original shape, to be in the same orientation as it was before. It looks the same after rotating 90 degrees. And if you do that 4 times, you'll come back to the exact way it was placed before. So the rotational symmetry is order 4. So we can't circle this. We need to only circle rotational symmetry of order 2. Now for parallelogram. You have to rotate this 180 degrees to make the parallelogram look the same again. So you have to rotate it twice to bring it back to its original orientation. That means rotational symmetry of order 2. And similarly, we can see the rectangle also shares the same property as the parallelogram, and so does the rhombus. This rectangle and rhombus are actually just parallelograms. This one has all 4 sides equal, this one has all angles 90 degrees, but otherwise they're just types of parallelograms. Anyway, that's our answer. Question 14. Sophia writes on some cards. Draw a ring around all the cards that show equivalent values. Well, let's just find the value of each in decimals. So we have this in decimals already. This 2 divided by 5 is 0.4. 8 by 20 is also 0.4. 4 by 100 is 0.04. 8% 0.08. 40% 0.4. So we have 1, 2, 3, 4 values which have the same number. So we can just draw a ring around all 4 of these cards, and that's our answer. Let's go to question 15. Use a pair of compasses to draw a circle with a diameter of 6 centimeters. The center of the circle is marked. Well, if the diameter is 6 centimeters, the radius will be 6 by 2, which is 3 centimeters. Now you can extend our compass by placing the needle here, and then extend it to 3 centimeters by placing a ruler there, and then let's say 1 centimeter to 3. So at the 3 centimeter mark, we place the compass pencil, and then make sure the pencil is tightened, and then just draw a circle with radius 3 around the center. Let me just move this so it looks more like that's the center. Well, this is how it should look once it's done. This length over here has to be 6 centimeters. That's our answer. Let's go to question 16. Here's a coordinate grid where point A is marked. A. Write the coordinates of point A. We can see that point A has an x-coordinate right between 1 and 2, which makes it 1.5. And its y-coordinate is on the dot at 3. So we just write that in the second blank. So 1.5, 3 is our answer. Part B. Point B has the coordinates 4, 0.5. Plot this point B on the grid. The x-coordinate is 4. So we can draw a line x equals 4. Now, y-coordinate is 0.5. We can draw a line y equals 0.5. The point where they intersect is the point we need. We can erase the 2 lines now, and we have this point as point B, 4, 0.5. Question 17. Jamila makes a shape with black and white counters. Write the percentage of the counters that are white. How many counters are there in total? We have 1, 2, 3, 4, 5, and then we have 4 columns of 5 counters. So 5 times 4, which is 20 counters. How many of these are white? There are 4 of them which are black on the corners, so the rest of them are white. So 20 minus 4, which is equal to 16, which are white. And yes, we just know there are 4 black. Well, the percentage of counters that are white will be the number that are white divided by the total number multiplied by 100%. That'll be equal to 16 by 20 times 100%, which is 80%. And that'll be our answer. Let's go to question 18. Question 18. Yusuf has a coin. He flips the coin 4 times. He records the outcome each time, and here is the results. You have heads, heads, tails, heads. Yusuf thinks that the probability of getting a tail is 25%. Yusuf wants to improve his experiment. He thinks of 4 different methods. Take the method that produces the most reliable estimate of the probability of getting a tail. Well, what in this case is a more reliable result? The thing we need to do is to flip the coin more number of times. That'll give a better result. Doing trials with a different coin, flipping the coin higher or asking someone else to flip it don't really do anything. Just the number of trials matters. Higher number of trials is more reliability. That is our answer. Do 10 more trials. Let's go to question 19. Write a number in the box to make the calculation correct. Dash minus 12 equals negative 20. Bringing the minus 12 to the other side, that becomes plus 12. So minus 20 plus 12 will be in the box. That's just minus 8. That's our answer. Question 20. Samira has 4 beads and 2 pots. She puts the beads in the pots. A represents the number of beads in one pot, and B represents the number of beads in other pot. Write all possible sets of values for A and B. Well, there are 4 beads and there are 2 pots. Firstly, you can put all the beads in one pot. So let's say you put all of them in the first pot. Then instead of putting all of them, you just remove one from the first pot and put that one in the second one. So that's 3, 1. And then do that again, and again, and again, and that's our answer. Question 21. A table has a rectangular top. The length of the top is 2 meters. The width of the top is 3 by 4 meters. Calculate the area of the top of the table. The area of the top is of course going to be the area of the rectangle. And the area of a rectangle is written as A equals length times breadth. So that's going to be equal to 2 times 3 by 4, which is 3 by 2 meters squared. That's our answer. Let's go to question 22. Question 22. Carlos uses digit cards to make a 4-digit number. The number is divisible by 9, write the missing digit in the box. If the number is divisible by 9, all the digits will add up to 9. Or at least a multiple of 9, but in this case it adds up to 9. 3 plus 1 plus 4. That's 8. So the last digit must be 9 minus 8, which is 1. That's our answer. Question 23. Lily chooses an improper fraction. She says the numerator is a multiple of 2. Denominator is less than 6. The value of the fraction is greater than 1 and less than 2. Write a fraction that Lily could choose. Well, the numerator is a multiple of 2. So let's take any multiple of 2. Let's just say 2 itself. The denominator is less than 6. Well, so that means the denominator has to be either 5, 4, 3, 2, 1. But then 5, 4, 3, and 2 don't make improper fractions. 1 makes improper fraction, but then the value of the fraction has to be less than 2. If you add 1 here, it'll be equal to 2, which is not less than 2. So 2 cannot be the number here. Let's take 4. Well, the numerator is a multiple of 2. 2 times 2 is 4. Denominator can be less than 6. So 1, 2, or 3 because it has to be improper fraction. Now the value of the fraction has to be greater than 1 and less than 2. So the only one which works is 3. Answer we can write as 4 by 3. There are a few other values like 8 by 5, 8 by 5, or 6 by 5 are 2 examples. And yeah, that'll be our answer. Any one of these you can write. Question 24. Ahmed fixes chains between some posts. The length of each chain is 1.8 meters and he uses 14 of them. Calculate the total length of chain Ahmed uses. That just means you multiply 1.8 times 14. That'll make 25.2 meters of chain. That's our answer. Question 25. Here are the first 5 terms of a sequence. 9, 18, 27, 36, 45. Yuri says, I can keep adding 9 until I get to the 20th term. I can also calculate the 20th term without using addition. Write a calculation to show how to calculate the 20th term in the sequence without using addition. Well, the calculation we can write is just use the first term. So you have the first term, which is 9. And then how many more terms do we need? So that's 20 minus 1, which is 19th term from the first one. Or 19 to the right of the first one. So that means every time you add 9, so you have to add it 19 times. So it'll be 9 plus 19 times 9. What we did here is just the a plus n minus 1 times d formula for the nth term of a sequence, and where n is 19, d is the common difference, which is 9, a is the first term, also 9. So this is just going to be equal to 180. That's our answer. Question 26. A library wants to know if older children borrow more books. The library records the ages of children and number of books they borrow in 1 month. Here are the results. Tick to show whether the statements about information in the graph are true or false. In general, as the age of children increases, the number of books they borrow decreases. Well, we can see that this graph kind of looks like it's sloping downwards. So, if one increases, the other decreases, we can see. Over here, as the age of children increases, the number of books decreases. So, it's true. 14-year-olds borrow more books than 13-year-olds. Well, if you look at 14-year-olds and 13-year-olds graphs, the 13-year-olds borrowed 2 and 3 books, while the 14-year-olds borrowed 4, 5, and 6 books. So, of course, this is true as well. There are more books for the 14-year-olds. 2 children each borrow 10 books. Well, at the line 10 books here, we have 1, 2, 3 dots. So it's not 2 children, it's 3, so this is false. Question 27. Here's a shape drawn on a grid of squares. The side of each square is 1 centimeter. Take all the expressions that can be used to calculate the area of the shape in centimeters squared. Firstly, 6 squared plus 2 squared. This is correct, since we can split this into 2 separate squares. This one has length 6, this one has length 2. There's one option, 6 squared minus 2 squared. Well, that does not work, because we have 2 squares and you have to add them up, not subtract them. Next, 6 times 4 plus 2 times 4. Well, this is wrong, because how you gonna make a rectangle with length 6 and width 4 and length 2 and width 4 to fill the whole thing? This will be length 6 and width 4, this will be length 2 and width 4, or you can do it length 4 and width 2. It's the same thing, same rectangle. There's this much space left, we need to cover this as well. Now 6 times 6 plus 4. Well, the area of the square will be 6 times 6. And the area of this square will be 4. So this calculation works. 6 times 4 plus 4. Well, since we know 6 times 6 plus 4 works, 6 times 4 plus 4 will definitely not work. As a representation on the diagram, this will be 6 times 4. And then we add 4, we'll add this. Where do we get the remaining space over here? We won't get it if we use this calculation. So these two are the answer. Question 28. Write a number in each box to make the calculation correct. Dash by 5 is 1, 2 by dash. Well, since we're dividing by 5, of course the denominator here will be 5. Now 1, 2 by 5 can be written as 7 by 5. So this number has to be 7. That's simply our answer. Question 29. Chen chooses a 3D shape. Chen says, my shape has 2 triangular faces and 3 rectangular faces. Sketch a shape that Chen could choose. Well, if you think of this, you will think that there's a shape which is triangular prism. And we can draw that on isometric paper. So we can draw a triangle here. And then draw some lines. And draw the rest of the prism. So we have 2 triangular faces and 3 rectangular faces. That'll be our answer. Let's go to question 30. Anastasia has some rectangles and some squares. She uses them to make a cuboid. Each square has an area 25 centimeters squared, each rectangle 15 centimeters squared. Calculate the surface area of the cuboid. Well, the surface area will be 2 times length times breadth plus 2 times breadth times height plus 2 times length times height. So doing this, we get, since this is length, this is breadth, this is height. So 2 times 5 plus 2 times 3 times 5 plus 2 times 3 times 5. That'll be equal to 110 centimeters squared. We can use another method. Since we know the squares have area 25 centimeters squared, so there'll be 2 squares here, so one above and one below, which 25 centimeters squared, the area. So that's 50 centimeters squared. Now we have the other 4 faces are all rectangles of 3 times 5, which is 15, which will be given. So we do 15 times 4 since there are 4 rectangles. That's 60 centimeters squared. And now The surface area is just 60 plus 50, which is 110. That'll be our answer. Question 31. A rectangle and an isosceles triangle are on a straight line. Calculate the value of the angle marked A. Well, a rectangle is there, so this angle is 90 degrees. Now these triangles we can find because there is an isosceles triangle. So let's call this X. So X will be also over here. So 2x plus 80 is equal to 180 degrees. Since the angles in a triangle are up to 180. So x will be 180 minus 80 divided by 2. Using that equation, we get 50 degrees. So that's 50 and we have 90 here. A, since the angles on a straight line add up to 180 degrees, so this is 180 degrees. A will be equal to 180 minus 90 minus 50, which is equal to 40 degrees. That's our answer. Question 32. Here's a shape drawn on a grid of squares. Draw a reflection of the shape in the mirror line. Well, drawing the reflection on the mirror line basically means you have to reflect every single vertex of the shape. So let's reflect the one closest to the line first to get the idea. We can see that the shortest distance from this to the line is one diagonal unit because this is perpendicular to the line. That's why it's the shortest distance. Well, one diagonal unit from the line, and that means to make a mirror, we just draw one more diagonal unit in the same direction. So that'll be first point. Using the same thing, this is 5 diagonal units. So we go 5 diagonal units to get there. Now at third point, this one is 3 diagonal units. So we just go another 3 diagonal units to get here. And this is also 5 diagonal units, so it goes over there. Now all we have to do is join the dots. And if you understand this concept, this question is very easy. That's our answer. Question 33. Write the number on each line so that time intervals are equivalent. What has been done for you? 1 hour equals 60 minutes. Now the second one, 0.3 minutes is dash seconds. 0.3 minutes, we just have to multiply this by 60 to get 18 seconds. Now 2.2 hours, once again multiply by 60 to get 132 minutes. And 1.75 minutes, once again multiply by 60 to get 105 seconds. That's our answer. Question 34. Gabriella makes a spinner using numbers less than 10. She spins the spinner 1,000 times. Her results show that the probability of a number 1 is 25%. The probability of a number greater than 7 is 0%. Probability of a number less than 5 is 75%. Probability of an odd number is 50%. Write a number in each empty box so that the spinner produces Gabriella's probability results. Firstly, the probability of a number 1 is 25%. So that means out of 8, 2 of them have to be number 1s. So let's just fill these with number 1. 25% of 8 is equal to 2. That's why 2 of them have to be 1s. Now, the probability of a number greater than 7 is 0%. That basically means there cannot be any numbers greater than 7. Next, the probability of a number less than 5 is 75%. So that means out of 8, 6 have to be less than 5. And all 6 are already given. So we only have 2 more. And last one, the probability of an odd number is 50%. So these two cannot be less than 5 because all the 6 over here for 75% are already done. And if we add more, it'll change the probability, so we cannot add a number less than 5. So it has to be 5, 6, or 7. Why can't it be 8? That's because the probability of a number greater than 7 is 0%, so it can be greater than 7. It can be less than 5, and it can be greater than 7. So 5, 6, and 7 are left. And the probability of an odd number is 50%, which means 4 squares are filled with odd numbers. All 4 of them are already filled, so these two have to be even numbers. Now 5, 6, and 7, we can cancel the odd numbers to leave 6. So the last two are both 6s. That's our answer. And this is the only answer. Just write 2 1s and 2 6s. It doesn't matter where you place them. With that, I come to the end of the video. Please like this video, subscribe to our channel, share this video with your friends and family, and comment on how you think this video was. With that, it's me, Sanjay Vasu, signing out. Thank you. Bye.